This is the second video in a two-part series covering photovoltaic, also known as PV, and battery storage system requirements for non-residential and high-rise multifamily buildings in California. This Part 2 segment walks you through some examples of sizing battery systems. Part 1 looked at sizing PV systems, and because whichever method you choose for sizing the PV system will be used for finding its corresponding battery requirements, we urge you to check out Part 1 if you haven't already done so. There's a link in the description below. To recap some basic points from Part 1, you can achieve compliance with the California Energy Code using either the prescriptive or performance pathways. For now, we'll focus on prescriptive. Part 1 also summarized when prescriptive PV and battery requirements are triggered for non-residential and high-rise multifamily construction projects, as well as when they are exempt. In general, if PV is not required, then battery is also not required, and there are cases where the project might be exempt from PV and battery, but need to be solar ready. So let's consider battery storage and the prescriptive requirements for energy capacity and power capacity. A battery's energy capacity, rated in kilowatt hours, indicates how long it can supply power before needing to be recharged, which is essential for sustained energy supply. A battery's power capacity, rated in kilowatts, determines its ability to meet instantaneous power demands and respond quickly to fluctuations in energy usage. Back in Part 1 of this series, we introduced the two methods used to determine PV capacity, the conditioned floor area, or CFA method, and the solar access roof area, or SARA method. Whichever method you use for the PV system, CFA or SARA, you'll also use to find its battery requirements. Let's continue with our example of a high-rise multifamily building in Climate Zone 3, with 100,000 square feet of conditioned floor area. Since we ended up using the CFA method to determine its PV system capacity in Part 1, we'll also use the CFA method here for its battery storage. The CFA method for battery energy capacity uses a formula that considers the conditioned floor area subject to the PV system, a battery capacity factor determined from Table 170.2-V in the Energy Code, and the round-trip efficiency of the battery, a value commonly obtained from the manufacturer's datasheet. Continuing with that example building, we have a battery capacity factor of 1.88 from Table 170.2-V and a battery round-trip efficiency of 95%. The formula is in two parts: the CFA multiplied by the battery capacity factor, divided by 1,000 times the square root of the round-trip battery efficiency. So we multiply 100,000 by 1.88 and divide that by 1,000 times the square root of 0.95. We end up with 188,000 divided by 974.68. When solved, the minimum energy capacity for the building's battery system is 192.9 kilowatt hours. To find the minimum power capacity for that battery system, divide its energy capacity by 4, which, in this case, is 48.2 kilowatts. The SARA formula for battery energy capacity looks very similar to the one used for CFA. It just takes the CFA formula and inserts a final adjustment factor. Now suppose another building has 3,000 square feet of low-slope roof, resulting in the lower PV capacity of 42 kilowatts with the SARA method. We divide 42 SARA-derived kilowatts by 182 CFA-derived kilowatts to obtain the final adjustment factor of 0.23. Multiply 192.9 kilowatt hours by 0.23 for a minimum battery energy capacity of 44.4 kilowatt hours using the SARA method. We get the rated power capacity for this SARA-adjusted battery system by dividing the energy capacity of 44.4 by 4, which is 11.1 kilowatts. Finally, if you use the performance approach to evaluate the whole building, including the proposed PV and battery system, the required PV and battery systems will be whatever is indicated on the compliance report, which may be less than or more than the prescriptive calculations described in this video. Leave us a question or comment below, and see our list of resources pinned in the comments to learn about other Energy Code ACE offerings on this topic.